Hi all, in this video I'm going to do one more filter. In this filter I create a random number of randomly sized rectangles. Within those rectangles I tint the pixels a random amount. And here I have a picture of Sydney Harbor and I'll run the filter on it, which is called Tint Blocks 3. And you'll see that it creates a bunch of rectangles. And within those rectangles, the image that is tinted a bit. So I'll just run it one more time to show you. Every time you run it, you get a different pattern of rectangles because everything's being randomly changed. Okay, so let's take a look. Tint Blocks 3. Standard thing, we make a two-dimensional array of pixel objects. We get their width and their height of the two-dimensional array. Now we generate the number of rectangles, number of blocks I call it here. And to do that we multiply 200 times math.random. This is using the built-in random function that you need to know how to use for the AP. Math.random generates a real number between 0 and 1. We multiply it by 200 and we get a real number between 0 and 199. We multiply that by 100 and we get a number between 100, we add 100 to that and we get a number between 100 and 299. Plus there's a decimal value, right? So we int it to get rid of that. So that leaves us with a number between 100 and 299, right? 100 between 100 and 299, rectangles. And that's generated each time you call the method. The tint shift size is the amount of shifting of the colors up and down, the maximum amount, which is 40. There's some variables for storing the shift amounts and the new values for the red, green, and blue. So we have a loop here which loops the number of random blocks. In it we generate the top left corner. That's what these first two lines do. The height of the two-dimensional array times math.random minus 20. I do the minus 20 and the minus 40 here so that some of the rectangles will start to the left of the image and some will start to the above the image, because that's to counterbalance the fact that some of the rectangles are going to overlap the right side and overlap the bottom of the image. Right? These two lines generate the width and the height of that particular rectangle. And we move on to the amount of shifting of the tint. Here we calculate the amount to shift the red, blue, and green. I won't go into I'll quickly go into this. We do tint shift size is equal to, redshift is equal to tint shift size minus math.random, again that's a number between 0 and 1, times 2 times tint shift size plus 1. So what we want is to be able to shift equally up or down in tint shift size. So by subtracting 2 times the tint shift size from tint shift size, or some number between 0 and 2 times tint shift size, we are able to correctly randomly shift the colors up and down. We do this for the red, the blue, and the green. Then inside of a standard nested loop in which we go through all the blocks, in this case all the blocks within the rectangle in which we're shifting the colors. And then because it's possible that some of the row and columns that we've generated are outside the bounds of the image, I do a check for that to make sure that we only deal with them if they're inside of the image, otherwise we skip right over them. We get the pixel at that particular row and column, once we've determined that that row and call position are actually within the image. We set their, we get the current red, blue, and green values, and we shift them. Yes, we get the current red, blue, and green values. We add the shift amounts to them. Then we check to make sure that they're within the specified range, 0 to 255 for each of the colors, red, blue, and green. And then we reset that pixel at the row and column position to a new color using the shifted red, green, and blue values. That's it, right? So I hope that you will all be getting your filters into me as soon as possible. Next week we will be starting a more formal review process for the AP. Thanks.